So in this video we will be making a square beam and we will be doing a topology analysis or simulation. So topology analysis in which it is to remove material and to optimize the performance. So moving on, let's make our drawing. Okay, let's make a square beam. Okay, let's define our length to be 50 and width to be 50 and length to be 75 and deck. Let's draw again. Okay, let's make this length 75 and let's make this 100. Okay, let's make it 100 and this is 75 and this 150. Okay, feature to extrude. Feature in this case we do not need to extrude. As you can see, this is your beam. Let's edit it and make it of 1000 millimeter, which is 1 mm. And here we go and go to add in simulation. Okay, click on simulation, new study. Okay, what I need is topology. Okay, there is some issue. Okay, here we go. Let's select Solidworks Premium, go to simulation, new study and click on topology study 1. Okay, that let's take it and now for the part let's apply material. Let's take alloy steel and let's move to fixtures, fix geometry. This is fixed. Now let's add pressure onto the surface. Let's say 980. You can also divert the direction. Okay, no, it will change according to. Okay, so this is fixed support and I have added the pressure. You can also add force or torque in it. Okay, let's set up our control. Okay, stiffness, displacement, let's reduce mass by 50% and the let's take the stiffness to weight ratio and apply tech. It is applied and now moving on to manufacturing controls. Okay, so basically manufacturing and control is there are different techniques in which you specify the geometry from where and how to remove the material, or basically you restrict the removal of material. So click on add preserved region. So basically what I am doing is that the material in this phase, the material will not be removed, the material will be restricted and will not Okay, let's take a clearer view and let's select this, this. Okay, preserve area. So basically I'm gonna take the value of 2 millimeter, and basically it is the restriction around the area as, or it acts as a safety factor for it. Let's tick and move toward demolds direction. Okay, let's add here, press tick and specify symmetry of the plane. Let's say top right plane, it will act as a symmetry. Let's create mesh. So you can change the mesh quality, or basically this means your mesh will be fine or coarse. In this case I will be doing a little fine. Okay, and here are some mesh parameters. These are the element size. Okay, let's do tick, and here's our mesh is done, as you can see. So let's run this study. It will take some time as I have reduced the number of size of the mesh elements. So I have reset the mesh element size and click on view convergence, and to see the graph, this is your convergent graph, and this is the target value, which is 50% mass reduction, and this is your result. No iterations are still going on. Wait, you can see 9. Okay, this is your topology topology. As you can see, this is the material you must keep, and it is okay to remove this one. So this is your topology analysis. As you can see, you can also change the material mass, heavy or light, to remove 50%. You can change it, and this will tell us how much material can we remove, and how much can we remove and cannot remove. Let's say I take it the cursor to, as you can see, this part is okay to remove. Let's check if we heavy means that we will be removing less mass, less material, and light means we will be removing most of the material. As you can see, the most of the material is removed. This is it. So that's all for today, and this is a field problem. I will be doing this topology problem on ANSYS workbench soon, and I will upload that video too.